So in modern web applications, what we definitely want to do is to optimize that so-called startup time. Because contrary to server-side render pages where the HTML is already ready, in modern applications, in single-page applications, we first need to download a bunch of JavaScript that needs to be interpreted by the browser, and then only we can start the app which renders the HTML. Now, there's a metric that is called time to interactive, and we definitely want to optimize for that. So one countermeasure we can apply here is to not always load the entire application at startup. So basically to reduce the number of files we have to actually download, and we just want to use the necessary ones to get our application up and running. So for instance, right now, if I go to that application and the network tab, then I filter here for the JavaScript files, I do a reload, and we see the files get downloaded. Now, if I click that button here, we get to a new route of our application. But if you take a look below here in the JavaScript section, nothing actually changes. And the reason here is that the entire app gets already downloaded at startup. So for the purpose of this exercise, let's try to lazy load this part. So whenever we switch to this Nyan route, we actually just want to download at that moment the necessary JavaScript files to run and visualize it. So let's go back here. And let's take a look at the structure of our application. So if we take the folder structure here, we see that folder Nyan. And actually, I want that these two here get bundled into its own JavaScript file. And so that is necessary, and this is a mechanism called code splitting, such that later at runtime, we have here a dedicated JavaScript file just having these components here and just get interpreted and loaded at that specific moment. So how can we do that in Angular? Now in Angular, the Angular CLI already has a mechanism to create this on the fly. For instance, let's paste in this comment here. Now here we use the ng command, which is the Angular CLI. We generate a new module. We give it a name. Then we tell it should get hooked up to that app module. And then we also give it this route path. So we want to generate here a route, and that would generate a lazy loaded route that just gets loaded at the very specific moment when it is needed. Now, since we already have the entire code here and we don't want to override everything, let's try to do this by hand to see the various steps that are involved here. So first of all, what I need to do here is to create a new Nyan.module. This is because in Angular, the minimum unit that can be lazy loaded right now is a module. And so we need one of those. So we have here an ng module. I export class and we just call it Nyan module. And then we definitely have here a declaration section. We want that now that Nyan component, which right now is registered here to an app module, is now registered to that Nyan module. So I would fetch in that one here. And in the import section, we want to define here now a separate route. So right now, if I go to the app module, you can see here the route is defined inside here. We want to split that out into that Nyan module. Let's see how. So first of all, I need the router module. And we use the for child. Let's first import it here. Because this is now a child route and not in control of the entire application, but just a part of the entire routing system, right? And so the path here will be nothing. And we will see why. We have path match full because it's an empty string. And the component that should get loaded is obviously our Nyan component. All right. So with that, we should be already set up in our Nyan module. Now we need to do the lazy loading part. So let's go over to the app module. And first of all, we need to remove that hard reference here because we cannot directly import here a JavaScript file because otherwise that will get fetched into our main.js file. And actually what we want is to have that in its dedicated own bundle. And so we cannot have any hard references. And so let's remove here this Nyan component, which is registered anyway now in that Nyan module. And now we need to change obviously this line here below. Since we don't have the component at hand right now, but it will only be available at runtime later, we can use the load children property here. And starting with Angular 8, this takes a function where we can directly use now that import statement. And so I go here to that Nyan module, which we just created, because that's the part we have to lazy load. We cannot lazy load the component right now. And then we use here the callback where we get here our Nyan module. Great. All right, so let's save this here. Now let's go here to our application. We can see here we have that main and files loaded. And now whenever I click here that Nyan button, you can see here that another JavaScript file gets loaded in. So the Angular CLI now has detected that we had here this load children with that import statement. and automatically for that module it generates a new separate JavaScript bundle, which is called a mechanism called code splitting, and it loads it only when we actually navigate to that route. As you can see again, if I refresh here, we just have again our main files, and once I click, this necessary files get loaded in on the fly over the network, our application module gets booted, and we see the image just as before. So this application here improves the time to interactive by applying some code splitting mechanism, as you can see here. So only when we click here that button, in fact, let's prove that. So initially we get these files here, and then when the button is clicked, the additional JavaScript file gets loaded in just for visualizing that specific route. Now, obviously, once we transition from one page to another, that downloading of that file, obviously depending on our network connection and also on the size of that file, may take a while. So what we want to do here is to visualize here a loading indicator. So first of all, let's go to that app component, which has the router outlet, which basically visualizes here our components. And so inside here, we paste in such a span with a loader class that gets visualized when that loading flag is set to true. So don't worry about that loader here. There's a bunch of CSS behind that visualizes an animation. But we're not quite interested into that, but rather how to visualize that, how to show that and hide that. As we said, this happens with this loading flag. So first of all, we need to define that. This is a Boolean. And then in the constructor here, we need to initialize that. So first of all, let's say this is equals to false because we are not loading at all. Let's also save here our app component HTML. Now we need to understand when the loading should start and when it finishes. And that happens basically in our case with the router transition. And so whenever we click, a routing transition happens and then it terminates at some point. And so here we can use that router, and we can obviously fetch that via the dependency injection from that Angular router package. And that router now exposes different kind of events. So we can first of all subscribe to those events. So here we have an event, which is a router event. So basically, if that event is an instance of that route config load start event, which we need to import, of course, then we want that loading animation to start and to visualize. Else, if that event is an instance of that route config load end event, we want to hide it again. All right, so now let's save this. Let's see where this works. Actually, you can see it very briefly. Let me here refresh and then throttle the connection a bit. So if I click, you can see that loading, and then the new page gets visualized. So this application here uses Angular's lazy loading mechanism to code split out these modules into separate files, which are then only loaded on demand when they are needed. And this drastically improves the time to interactive, so the startup speed of our application, but it also comes a bit with the cost of navigation delay. And what I mean with that is, for instance, the following. Let's open up here the DevTools. Let's do a refresh of our application. Now I switch to a slow 3G connection. And now if I click here that button, you can see the JavaScript file gets fetched from the server. It takes some time to interpret and load up, and then only it gets visualized. Similarly, also here with that about screen, you can see it takes some time to download it, and then only we see the page here pop up. Now, a countermeasure we can apply here is a preloading strategy. And luckily, Angular has something like that for us already in the framework. And so what we can do, first of all, to configure that. So if you go to the router module for root, then we have a second parameter here, which are various options we can pass into our router. And one of them are the so-called preloading strategies. And here we could specify our custom preloading strategy we define, or just specify the preload all modules strategy, which comes built in with Angular. Now, what this does here, it gets imported first of all from the Angular router package. And the main function behind is that the application gets booted up quickly because only the necessary parts are actually bundled into the main.js file. And then once the app is running in the background, the other files get fetched from the server and already prepared and loaded into our browser. We can see what the result is of the corresponding optimization. So first of all, let me go here back to the root of our application. We refresh, you can see the main files arrive, and then just a bit after, these two lazy loaded bundles also get downloaded, even though I didn't interact with the application. Now, of course, you can imagine everything is already downloaded. I can just click the button here and I get the root visualized. But for instance, in the about screen, if I click, it is here already interpreted and ready to be shown to the user. When lazy loading Angular modules, we obviously optimize for that startup time, but on the other side, we have some navigation delay. And in this application here, the preloading strategy, preload all modules, is being used to circumvent that. However, this is quite a drastic approach, because if we open up here the network panel, we can actually see that the main files get downloaded and then all of our lazy loaded modules get downloaded as well. Now that might be completely unnecessary, because we might want to get a better control over which modules get downloaded immediately and which only when the user clicks on them. And so what we want to do here is to define our custom preloading strategy and not to use that one built into Angular. So the first step is to create a new file. Let me call this custom preloader.ts. And I paste in here some scaffold. In the end, it is normal Angular service, as you can see, an injectable. It implements that preloading strategy, which comes from the Angular router package. And that preloading strategy here defines that preload function. That preload function takes a route, and that route gives us information over which route is about to be activated. And then we have here that load function, which if invoked, the corresponding route here gets preloaded, otherwise it won't be preloaded. Now, let's define how our configuration should look like. So what I want to do is, for instance, that 9 module is a module which here is in the home component, and I want to immediately preload that because the probability that the user clicks on this is quite high. So I go here and I want to use the data property which we can attach to a route. And I want to specify here a preload Boolean flag. And if that is set to true, then I want to preload that route, otherwise I don't want to preload. So the final result would be that 9 gets preloaded and the about page on the other side won't get preloaded. So let's save this for now. Now let's go and implement that. What we want to say here is that if basically our route dot data contains such a preload, and in general if the route dot data is defined and it contains a preload, then we return that load function and invoke it immediately so that route would get preloaded. Otherwise we just return an empty observable, and so nothing would actually happen. Now let's save this. We also need to go back into our app module, and now we can use here our custom preloader and comment out that preload all modules strategy. So if I refresh now, you can see the main files get downloaded as well as our 9 module, which we specified to be preloaded. However, that about module gets only loaded once I click actually on that file. So this Angular app has various lazy loaded route, and it uses a preloading strategy to preload the modules once the application is idle and already up and running. Now, it already uses here a custom preloader, which is definitely better than a preload all modules, which comes baked into Angular, because a preload all modules downloads all of our modules, which might not be necessary. Rather than creating a custom preloader, we also might want to use the ngx quicklinks. It is basically an extension of that quicklink library from Google Chrome Labs, which once the viewport is idle, it prefetches the links that it sees on the page. And Minko Gachev has created a similar one, which is a wrapper for Angular, and he called it ngx quicklink. And so the first step, of course, is to install it. And we can do an npm e ngx quicklink and install that library into our application. Now, once it is ready and installed, we can go and actually use it. Let's first boot our application again via the Angular CLI. And so the first step is to import here that quicklink module, which we need to import from ngx quicklink. And then the other export here is the quicklink strategy. And that quicklink strategy is the one we actually use here instead of our custom preloader. Let's save this. Let's see whether our Angular application still compiles and boots up. Now let's open the network panel and navigate to the JavaScript files. Let's reboot. Now you can see here we get that 9 module, which gets activated once I click this, already preloaded here in our network panel. Now if I open the side menu here, which contains that about page, you can see that also that about page gets preloaded immediately once it is visible here in our viewport. And so we don't experience any kind of delays once we click on those buttons. which is a really cool strategy for automatically determining and preloading only what the user actually sees on this page. One of the key goals when you want to build performant applications, or in general when you want to improve something, you have to take measurements. And those measurements help you to understand how well you actually perform or how badly you perform. And as well, you can see how you optimize over time. Now, one of those measurements can be the so-called performance budgets. Luckily, the Angular CLI has a way to specify budgets during the build time. For instance, if we go to our app here, which is a simple application which we have, and we go to that Angular JSON, we can go to our main application, which in this case here is our ng-perf. We scroll down, we go basically to the configuration, and we're actually interested here in that production section. What we want to do here is to specify so-called budgets. And budgets allow us to specify various sizes we don't want to exceed. For instance, let's take a look here. First of all, we specify here the type. Now this is a JSON file, so we have to respect that kind of syntax. And what we want to do here is the type bundle. So we want to address a specific bundle of our application. The name of that bundle is the main bundle. That's basically the one that contains the main application parts. And then we can specify here different kind of thresholds. For instance, we can say a maximum warning. Let's give it here 350 kilobytes, just as an example. And then the maximum error. And here, let's say 500 kilobytes. Now, what this does is basically whenever we exceed this kind of threshold, it will give us a warning during the compilation. While this here will actually make our build fail. And this is extremely important, especially if you have a continuous integration environment. Now let's give this a try. Let's save this. Let's run ng build --prod for the production build. Alright, so once the second build also finishes, you can already see here that we get a warning here. Warning in budgets, maximum exceeded for main, which we specified before, and that budget was specified to be 350 kilobytes and was exceeded by 72 kilobytes. And so you can already see that warning. You can now already take action or for now ignore it. Now let's artificially increase that size to get also the maximum error which we specified. So to do it, I open up the app component, and you can see here at the very top we have some import from RxJS. And now these are already optimized. However, if we import an internal package here, so from internal operators rather than directly operators, as you should actually do, we will artificially increase that bundle size of our application. So let's redo that build. Alright, and once the build finishes, you can now see that we get the warning, but you also get the error which actually makes our build fail because we exceeded our 500 kilobyte budget, which we have specified by 44 kilobytes. And that's actually exactly this main bundle which we have specified before. Now what we configured here is actually the main bundle. But if you take a look here at this budgets definition, you have various types what you can specify. For instance, all or script, any script bundle, or the initial size. Now, if you want to know more, you can go to the main Angular IO documentation and go to that build section where there's an entire section on how to configure size budgets, as we just did. And furthermore, further down here, there is exact definition what the bundle means, what initial means, what all script, etc. So here we have a simulated business application, which has two different kind of lists of employees. One which belongs to the Department of Sales and one that belongs to the R&D department. Now, if I click in here, I write something, I hit enter, you can already see that the application is quite laggy. So we will get here a name that entered. I can jump over here, do the same, but you see that there is a huge delay on what I typed and actually when it gets rendered. Now we want to optimize that kind of application. So let's see how it is actually structured. Let me make this a bit smaller again. So what we have seen here are these two adjacent lists. These are both coming from the app employee list. They're just getting feed with different kind of data. Now, if we go inside here, we see that we have here our app employee list, which renders the data that comes in via here that input. And then for each item in the row, it calculates here that number based on the input it gets. So we see here that calculate function. That calculate function resides here in our component, which makes here a so-called simulated business procedure, business calculation, which is quite costly in this case. It calculates the Fibonacci number. Now, one thing we can optimize in Angular applications often is the change detection cycles Angular has to perform. Generally speaking, it is actually quite fast, but in certain cases we can actually give it some help. So let's take a look at our component tree. So what we have here is that app root, which is the very top, and then we have that employee list, which is the one from sales, and the employee list from R&D. And here our app root in between. So this is kind of a tree structure. Both of these employee lists below have different kind of rows below, right? So we have here the employee list for sales as well as the employee list for R&D. Now, whenever we insert something here in our employee list for the sales part, what happens is that at the very top here, the change detection cycle kicks in because it has detected some changes, and it will go down on both on the employee list as well as on the employee list for R&D and recompute every row, which means recompute Fibonacci for every entry here in those lists, in both of them. Now, already in this case, we could optimize by telling Angular, look, we just changed here something on that side, so you can actually avoid doing the change detection for the whole part of the employee list in the R&D section. So let's close this and see how we can do that. In our app employee list, we can actually go down in our component definition, and there's a property called change detection, which you can set to the change detection strategy.onPush. OnPush will actually now trigger change detection only if the reference of the data passed here via the inputs has actually changed. So we got a new list of data. Now this obviously happens here for the sales department once we type in here a new person, but it doesn't happen for the R&D part. Let's see whether our performance increased here. Let's type in here. You see the animation is already faster. And we actually get already a better performance. But there's still some lag in the application. Let's see how we can further improve it. Now another point we can improve is this calculate here. This happens for every entry in the list every time we change that list, right? This is something we can actually avoid because we know if you go to that calculate function that whenever we call Fibonacci with a certain number, with the same number we will always get the same result. So we actually can avoid doing the recomputations every time. That's because Fibonacci is a pure function. Now what we can do is actually to use Angular's pure pipes to help us improve here the performance. So let's generate here a new Angular pipe. And we do that with the ng command, with the generate operation. We call it pipe and we place it into the employee list and we call it calculate. For now we skip the tests and this creates a new calculate pipe here and it also inserts it properly in the employee list module. So let's go and have a look here at our pipe implementation. Now let's refactor our employee list and move over that logic. First of all, we can move over that Fibonacci calculation, which will happen here. So we get here a number, which is a number we pass ahead to the Fibonacci calculation. And here we just return the result of that Fibonacci. Now, obviously, we also need to move over the Fibonacci function, which we can just here cut out. And let's also here remove that function, which is no more needed. Let's move that over to the very top here. And so here our pipe is actually done. Now, Angular pipes are pure by default. We can change that via that setting here, which is called pure, and set it to false in case we have a non-pure pipe. Meaning pure means that whenever the same input comes inside here, that value is not calculated anymore because Angular knows it has seen it already before and just returns the result. So let's save this for now. We can now go over to our employee list, which we need to refactor because that calculate function doesn't exist anymore. So we can remove here this. And we can now use our new calculate pipe. Now let's save again. Let's here make our window a little bit bigger. Now let's type in. You can see how fast the typing now works, right? I can type in new values and it's really speedingly fast. So we have actually taken two measures. First of all, the change detection, which we changed to onPush, and then we introduced a pure pipe to optimize our computation, which happens inside our lists. So this is a very stupid application which will help us showcase the performance issues of having enormous amount of DOM elements inside your page. So as you take a look at this application, we have here a main component where we have an ng4 which iterates over that list, and that list is actually an array of 100,000 entries. And in fact, if we go over here and scroll down, you see a huge amount of elements. Let's open the element panel a second. If I open here at AppRoot, you can see I click. There's even a lag in the Chrome DevTools of opening up here all those divs which are inside that AppRoot component. In fact, also if I refresh the page, you can see the delay in the startup time. So what we want to do is now optimize this, because actually we don't want to render all of the items, but just those items the user actually sees. This is what is called virtual scrolling. If you go over to material.angular.io, we have here a section CDK, which is the component development toolkit, which is a set of components which are independent of material design, which would rather help us create better and more performant application. And one of those components which you have is the scrolling. And that scrolling has also a virtual scroller in place, which we will use now to optimize our application. So the first step is obviously to install the Angular CDK, and we do that by npm install at Angular CDK. Now I have already installed that. If you go to the package.json, you can see here the CDK being installed. And so the next step is to actually use that scrolling module. Now let's go back for a second to the documentation. Let's go to the very top. We can see here that scrolling module. So let's copy that, go over to our app module and import that as usual. And we will reference it here in the import section, of course. Once we have that, we have our application set up. Let's go to the app component, and we want to make this actually virtual scrollable. And so what we have to do here is to use the CDK virtual scroll viewport. Let's enclose our whole template into that tag here. And that virtual scroll viewport needs a couple of inputs. You will also see this if you save it for a second, then go here to our console, and you can see then we get an error because we need the item size. The item size is how big basically our entry is in our list, such that then the virtual scroller can calculate how many items will actually fit in the current viewport. So let's go here and specify the item size, let's say 18 pixels. And then we also want to limit the height here of that whole scroll viewport. So let's say here style, height, let's save. You can now see the list is smaller, but we still have a lot of elements inside here. Let's open here the app root, CDK virtual scroller, which wraps it now. But as I open here the inner div, which hosts all of our DOM elements, still all of them are there. So it seems that virtual scrolling is actually not working. The reason is that we have to exchange here our ng4 with the one provided by the virtual scroller from the Angular CDK. And it is basically called CDK virtual 4. Once you have that, let's save again. You can now see already how fast our application is to boot up. So if I do a refresh again, you can see it's already here. Let's inspect here our DOM tree. If I navigate in here, the div, it opens immediately. You can see here the elements which are present on our page, which go until 23. Now, if I scroll, you can see that further elements are being added as I scroll, and the ones at the very beginning are being removed. So we always have a fixed set of elements inside here, which allows us to have basically fast scrolling, so the scrolling doesn't suffer in performance, but still we have a very fast startup time because only a finite set of elements is actually rendered on our page. This is a very simple application, but still we already tried to optimize it quite a lot. Meaning, for instance, if we refresh here, we see that we do some preloading techniques. So we download the 9 model only when it is actually needed. Also, we use ngx quicklink, for instance, that preloads assets once we navigate to them, such that they are already there when the user clicks then on the corresponding link. So we have applied quite some optimizations already. However, if we are in very bad network conditions, or even if the user is offline, we still have performance issues, of course. Now, one way to optimize that is to actually add some service worker and some precaching mechanism to serve the assets, the JavaScript files, and even images from the local storage rather than over the network. Let's see how we can do that in Angular. Now, Angular has a very nice package which is called ngpva. So we can use the ng add command at angular/pva to install it from npm and automatically configure our local application with the Angular service worker. Now, once this is installed, let's inspect here our app module. So in the app module, we see here we get that service worker module registered in our import section. It registers here that JavaScript file, and it enables that service worker only for production. So before diving into that, let's quickly create a production build to actually see that service worker in action. Now let's fire up an HTTP server on that port on the dist folder. Now if you go to localhost 1234 and refresh, we see here our service worker being installed. We even see the install command here popping up in Chrome. If we go here to application, we can also inspect here that our service worker has been registered and being received. And if we go to the network panel and refresh, we see that the service worker is actually serving our files. The boot up time is already really increased. Even if you go offline and we refresh, our application is still served and still works. There's only one issue, however. If you go to the 9, we see that image here doesn't get actually pre-cached. We can even optimize that. Let's see how. So with that installation of the service worker, we got actually a configuration file in our project. We scroll down here, we see that ngsv config. And if you open that, we see the configuration which Angular by default generates to pre-cache our application. Now if you take a look at that prefetch section up here, you can see that the favicon gets pre-cached, index.html, the CSS files, the JS files. However, in our assets folder up here of our application, we don't pre-cache that image. And so what we want to do here is to add another entry, which will also pre-cache that PNG file in our assets folder. Now again, let's create here a production build. Again, let's fire up here our static server. Let's go online and refresh. Let's go to our home part here, refresh again. Now let's go offline, refresh, and now if you click here on that button, also our image gets properly pre-cached by our service worker.